Welcome to the deep dive. We've got a fascinating paper to dig into today.
Oh, yeah.
It's called "Attention is All You Need."
Okay. I've heard of this one.
Yeah, and it's had a huge impact on AI,
Mm.
especially how machines, understand language.
Right.
But the title, I'll be honest, is a little,
Cryptic.
cryptic. So
Yeah.
our goal today is to,
Break it down.
make it clear, even if you don't have, a PhD in computer science.
I like that.
So imagine teaching a computer to translate languages. Well,
Okay, yeah.
but not just word for word, but like really understanding the meaning.
Like a human would.
Exactly.
Yeah.
And that's where this attention idea comes in.
That's a great way to put it. I am intrigued.
So let's think about how we read a sentence.
Okay.
You don't just process each word, separately.
Right.
You focus on some words more than others,
Right.
depending on the context.
Yeah, absolutely.
Like the cat sat on the mat.
Classic example.
Right. The word sat, it only makes sense because of cat and mat.
You got it. That's the whole point of context.
So in AI, it's the same idea. It's called attention mechanisms.
Right.
The AI can focus on specific parts of the input, like deciding which words are important.
And that's based on, what it's trying to do. Like, is it translating, summarizing?
Exactly. So before this paper, how are researchers tackling this problem?
Well, they were using models like RNNs and CNNs. These are,
I've heard of those.
yeah, they're for processing sequences of information like sentences.
Okay.
So RNNs, those are recurrent neural networks. They process information step by step.
Oh, so like reading a sentence word by word.
Exactly, one word after another.
Seems intuitive.
Yeah, it does, but it turns out RNNs have a big limitation.
Okay.
They have trouble remembering information from earlier in a sentence.
Oh, so if the sentence is long?
Exactly. They kind of forget what came before.
Like a short-term memory problem.
Yeah, you could say that. And then there's CNNs.
Those are for images, right?
You're right. Convolutional neural networks, they're great at finding patterns.
Like recognizing,
Objects in an image, yeah.
okay. But for language.
Well, they struggle too. They're good at local patterns, like between words that are close together.
Not for like the whole sentence meaning.
Exactly. So both RNNs and CNNs, they have these weaknesses.
Okay, I'm seeing the problem now. And that's where this paper...
Attention is all you need, yeah.
Right. It comes with a brand new architecture.
A transformer.
And it's all based on this idea of attention.
No more RNNs or CNNs, just pure attention.
Wow, that's bold. So how does this transformer actually work? I mean, it's going to be a whole different approach, right?
It is. And it's revolutionary. So instead of processing things step by step like RNNs, the transformer does everything in parallel.
In parallel. So it's not just one word after another.
Nope. It's like having multiple spotlights all shining on different parts of the sentence at the same time.
So it's looking at the whole sentence at once.
Yeah, exactly. And figuring out how all the words connect, even if they're far apart.
Wow.
And this is where multi-head attention comes in.
Multi-head.
Yeah, it's like having multiple experts, each looking for different types of connections between words.
Ooh, I like that analogy.
One might focus on grammar, another on meaning,
So it's getting a much deeper understanding of the sentence that way.
Exactly. It's not just about the individual words, but how they all fit together.
This is making a lot more sense now, and I bet this is a game changer for things like machine translation, right?
Absolutely. But we'll get into that more later. First, I think we should
dive deeper into how the transformer actually works.
Exactly. Right. Let's get into the nuts and bolts of this transformer.
Okay, yeah.
So at its core, it's got two main parts, an encoder and a decoder.
Encoder, decoder.
Just think of the encoder like a super reader. It's absorbing the meaning of the input sentence.
Okay, so the encoder, it's all about understanding what's coming in. And then the decoder, what's its role?
The decoder takes that encoded information and it uses it to create the output. Like, if you're translating, the decoder would generate the translation.
Okay, so encoder understands, decoder generates. Got it.
Right.
But where does the attention part actually happen? Is it in both?
It's in both. It's woven throughout the whole architecture.
Ah, okay.
So let's start with the encoder. Say it receives the sentence, the cat sat on the mat.
Okay, our classic example.
Right. The first thing it does is it breaks down the sentence into individual words. We call these tokens.
Tokens. Okay, so it's isolating each word.
Yeah, but it's not just about looking at the words one by one. The key is to understand how they relate to each other within the sentence.
Ah, okay.
And that's where self-attention comes in.
Self-attention. So each word is paying attention to the other words.
Exactly, but it's a bit more technical than that. Each word is actually represented as a vector.
A vector.
Right.
Like in math.
Kind of, but not exactly. In this context, a vector is basically a list of numbers that represent the word. It's like a unique fingerprint for each word.
Oh, okay. So it's like a code that captures the word's meaning.
Exactly. And then this is where the magic happens. The self-attention mechanism, it calculates a score for every pair of words.
The score.
Yeah, it's like a measure of how relevant they are to each other.
So like cat and sat would probably have a high score, right? Because they're closely related.
Exactly, you got it. And then these scores, they're used to create weighted combinations of the word vectors.
Weighted combinations. So it's like emphasizing the important words.
Got it. It's like turning up the volume on the important words and turning it down on the less important ones.
So it's creating a more nuanced understanding of the sentence that way.
Exactly. And this whole process, the comparing, the scoring, the weighting, it happens multiple times within the encoder.
Oh, so it's like it goes through multiple layers of analysis.
Right. And with each layer, it's building on the understanding from the previous layer.
So by the time it reaches the end of the encoder, it's got this really deep representation of the whole sentence.
Precisely. With all the connections, all the nuances, it's pretty amazing.
Okay, I'm following so far. So we've got the encoder, it's done its thing. Now what about the decoder? How does it take that encoded information and actually translate it, into French or whatever?
Well, the decoder works in a similar way, using self-attention to focus on the relationships between words as it's generating the translation.
Okay.
But it also uses something called encoder-decoder attention.
Encoder-decoder attention. That's a new one.
Yeah, this is what allows the decoder to refer back to the original sentence, the English one in our example.
Ah, okay. So it's like double checking to make sure the translation is accurate. Exactly.
It's like having a direct line back to the source material.
Okay, so it's not just relying on its own understanding. It's constantly checking back with the original. That's smart.
Right. And at each step, the decoder, it uses attention to choose the most likely next word in the translation.
So it's building the sentence piece by piece.
Exactly. And it's all guided by attention.
So attention isn't just for understanding, it's also the driving force behind generating the output.
Exactly. It's really the key to the whole thing.
This is all starting to click now.
Yeah.
So this transformer, it's using attention at every stage. That's pretty incredible.
It is, and it's what allows it to really grasp the complexities of language.
But I have a question. You said the transformer is really good at capturing those long-range dependencies, between words that are far apart.
Right.
But does that mean it has perfect memory? Can it remember everything it's read, no matter how long the text is?
That's a great question, and it gets to a limitation of the transformer.
Oh, okay.
So while it can handle much longer sequences than RNNs could, it still has a finite memory capacity.
Okay, so there's still limits.
Yeah. As the text gets longer and longer, the number of comparisons the model has to make, it just explodes.
So it needs more and more computing power.
Exactly. And eventually it hits a wall.
Okay, that makes sense.
Okay.
So it's powerful, but it's not, limitless.
Right. But researchers are working on ways to make transformers more efficient.
Okay, good to know. But even with those limitations, it's clear that this attention is all you need. Paper, it wasn't just about, making machine translation a little bit better.
Right.
It was about changing how we think about AI in general. It's like we're teaching machines to focus on what's important, just like we do as humans.
You got it. It's a paradigm shift.
And it's had a huge impact, not just on language processing, but on other areas of AI as well.
Absolutely. But we're just scratching the surface here.
I know. I'm excited to dive into that, to see how attention is changing the game in other fields.
We'll get there. We'll definitely get there.
Okay, so we're back. And I'm still kind of reeling from, all the stuff we talked about with the transformer.
It's a lot to take in.
It is. But what really blows my mind is that this paper, this attention, is all you need.
Right.
It was about machine translation, but it's had this huge impact on all these other areas of AI.
Oh, absolutely. It's way beyond just translation now.
Yeah, like it's changed how we think about processing any kind of sequential information.
Exactly. Whether it's, words in a sentence or musical notes or even frames in a video.
Wow. So it's not just language anymore. It's anything that can be seen as a sequence.
You got it. It's a fundamental concept.
Okay, so give me some examples. How is attention being used in like other areas of AI?
Okay. Well, one big one is text summarization. Like if you've got a giant research paper or a super long news article,
Oh yeah.
attention-based models can now create these really concise summaries, pulling out the most important points.
Oh, that would be so helpful. I mean, who has time to read everything these days?
Right. And it's not just about saving time, it's also about understanding,
Right.
Like a researcher can quickly grasp the key findings of a paper without having to read the whole thing.
So it's like attention is giving machines the ability to cut through all the noise and get to the heart of the matter.
Exactly. It's all about focus.
Okay. What else? What other areas is attention being used in?
Well, another exciting one is chatbots.
Oh yeah, chatbots. They're getting a lot better, aren't they?
They are, and attention is a big reason why.
How so?
Well, older chatbots, they were kind of clunky. They didn't really understand context or remember what you said before.
Right.
But now, with attention, chatbots can actually hold, more natural conversations. They can remember past interactions, they can understand nuances, and they can give more personalized responses.
So it's like they're becoming more human-like in a way.
In a way, yeah. They're becoming more like conversational partners.
Wow. So we're moving away from those robotic, scripted chatbots.
Exactly. We're moving towards something that feels more natural, more intelligent.
This is incredible. It's like we're at this turning point in AI where machines are becoming less like, rule-based systems and more like actual intelligent agents.
I think that's a great way to put it. And it's just the beginning.
Yeah. What else is coming down the pipeline? What other applications are there for attention?
Well, researchers are exploring its use in all sorts of areas, like image recognition, for example.
Oh, okay.
Attention can help models focus on specific regions of an image so they can identify objects more accurately or understand the relationships between different elements.
So it's like giving them a visual spotlight, kind of like we talked about with language.
Exactly. And then there's music generation.
Oh, wow.
Attention can be used to create, more coherent melodies that are more emotionally evocative.
So it's really impacting all these different creative fields as well.
It is. And I think we're just scratching the surface of what's possible with attention.
This is so exciting. I mean, it's amazing to think that this one idea from this one paper.
Attention is all you need.
Right. It's sparked all this innovation across all these different fields. It's like a domino effect.
Yeah, it really is.
Yeah.
It's a testament to the power of fundamental research.
Absolutely. And it shows how powerful ideas can really transform, entire industries.
It's true. And it's a reminder that we're still in the early days of AI.
Yeah.
Who knows what we'll discover next?
It's both exciting and a little bit daunting to think about,
I agree. But it's definitely a fascinating time to be involved in this field.
Absolutely. Well, this has been an incredible deep dive. We've gone from, demystifying this complex research paper to understanding how this one concept, this idea of attention,
right?
It's revolutionizing AI. It's pretty mind-blowing.
It is, and it's been a pleasure exploring it with you.
Likewise. And to our listeners, thank you for joining us on this journey. We hope you've learned something new and that you're as excited about the future of AI as we are. Until next time, keep exploring, keep those minds curious, and we'll see you on the next deep dive.